Who is hydrogen gas and what is the nature, use of hydrogen, and what does it look and how does it behave? Now we will. So let's do hydrogen. The point is, why are we going to do this chapter at all? What is going to help us through in our future? Human beings are extremely selfish creatures, and without knowing the implication of anything, we won't learn. So let us know, how is this gas going to help us and why are we studying this chapter, right? We have a wonderful news for you. We are announcing a new app called Let's, which is Let's Advance with Academics. Please download it from Google Play Store. The description box has the link. Here we are not able to provide all the things, but there every chapter, every numerical is solved. So happily learn. So before we go to watch a movie, we see that what is the introduction of that movie, right? So what is a hydrogen going to do to us? Hydrogen is a fuel which can be stored very easily in the liquid form. Hydrogen is a combustible gas and it's highly exothermic in nature. It is a lighter than air and it is used in meteorological balloons. What does it mean? It means that it is helping you to forecast the weather. Who is hydrogen gas and what is the nature? The nature of hydrogen gas is it burns with a pale blue flame which is almost invisible in the daylight, but for the graphical purpose we've shown you this. And the most important part about hydrogen is that it burns with a pop sound. Pop, like this, it makes a sound. Now we'll get to know the character of hydrogen. So when you get to know a person, you have to first know the physical feature. So these were the physical features, the coat, hat that he is wearing. And now we're going to know the actual chemical nature of hydrogen. Are you seeing this reaction? What are we dropping in that water? It is cold water. Okay. And we're dropping a piece of sodium there. So you see that sodium with cold water forms an explosion. Okay. So sodium, if it forms an explosion with cold water only, it can never react with acids, right? So do not react high metal activity series metals with acid ever. So now we are going to learn how to produce hydrogen with some metals. This is producing, what is the effect of this? The effect of this is it is also producing hydrogen as a byproduct. So let's learn what is the reaction of some metals with cold water and hot water. So after the explosion, we've got a little scared and we will never put hot water in them because in cold water only they're forming such an explosion, right? So K and cold water, which is 2H2O, it is cold. Whenever you give cold water to it, they will give hydroxide. Okay, and what is the easiest way to remember is all of them are 2. Okay, easiest way. So if we have a metal and if we have a cold water, they will always produce metal hydroxide, remember it. Similarly, Na plus H2O, write the skeleton diagram, you will know that they will produce metal hydroxide, which is NaOH. Hold on. Which is NaOH and H2. What is the trick? Put all 2, your equation is balanced. Okay, and Ca and H2O will give CaOH whole 2 and H2. Here just put 2 here, your equation is balanced. So we are seeing that all of them are producing metal hydroxide and we are seeing that all of them are the producers of hydrogen. Now we have a little lesser active metals which are magnesium, aluminium, zinc and iron, right? So magnesium is a little less active, so it needs a little motivation. Less active people needs a little bit of motivation, right? So what is the motivation? That means they need a little high energy. So he will react with boiling water. Boiling H2O. The moment they form, the temperature of the water increases, they will form oxide. Cold water hydroxide, this is oxide, okay, and H2. So this is the thing. And aluminium is even more lesser in the activity series, right? So even lesser people in the activity series, their form of water is not even boiling, it is steam. They will need steam, okay, and they will form oxides. So Al2O3 plus H2. What is the trick? The trick is this, just form this Al2O3, so 2Al, so 2Al, and 3H2O, so this will be 3 and this will be 3. So whatever is O, put H in the H there, your equation is balanced. Then zinc plus H2O, H2O is also in the form of steam, will form ZnO and H2. This is easy. Iron plus H2O, H2O is in the form of steam again because he needs motivation, he's a less motivated guy. It will form Fe3O4 and H2. Similarly, like this, we will do the same trick here. Fe3 means 3 and O is 4. So put 4 here, put 4 here. Your equation is balanced. This slide is for you to take down the equations properly in case my handwriting has been bad. Pause and take down. So if hydrogen has been produced by acids on metals, hydrogen can also be produced by bases on metals, alkalis on metals. So what are the metals we are talking about here? The metals are zinc, lead and aluminium. What are amphoteric metals? Amphoteric means they will react with acid also to give salt and water, and base also to give salt and water. Okay. So here they are reacting with alkali, NaOH. Any metal hydroxide is an alkali, to give Na2ZnO2. What is the name of Na2ZnO2? It is sodium zincate, which you have to know. Okay, this is known as sodium zincate. And with NaOH he is forming Na2PbO2. It is known as sodium plumbite. Okay, PbO2 is a radical which is called plumbite. AlO2 is a radical. This is an equation which most teachers would love to give, because here there is a water element which is here. So if the students do not know this, there is a chance of mistake here. So Al and NaOH plus 2H2O gives NaAlO2. AlAO2 is a radical which is known as aluminate. So his name is sodium aluminate. Okay, and hydrogen gas by default is coming out. Okay, now that we have learned that what is the use of hydrogen and what does it look and how does it behave, now we will be in a position to make hydrogen, because human beings are selfish and without anybody's use to our human life, we do not want to know them. But now we want to know them, so let's know them. Okay, this is zinc, and zinc in the laboratory preparation we prepare in a very small way, and in an industrial preparation we prepare in a little large way. Laboratory preparation is for children to just know, so that they grow up and make large scale preparations as when they start working, so that it comes to our use. So here we go with the small scale knowledge. This is zinc. Zincs are in granules. Why they are in granules is because they have some impurities in them which acts as a catalyst to speed up the reaction. And here we have drops of hydrochloric acid falling on zinc. So if we have zinc and if we have dilute hydrochloric acid falling, we have ZnCl2 plus H2. So hydrogen gas is coming out. And if we have dilute hydrochloric acid falling, we have ZnCl2 plus H2. So hydrogen gas is coming out. This gas which is coming out is lighter than air, so it wants to go up. And it is explosive with air. It does not want to. It does not have any quiet reaction with air. So we cannot take air. We have to put water out here. And why do we take water in an inverted position? Downward displacement is because it is lighter than air. It has got a tendency to get up. There should be no leakage anywhere because hydrogen forms explosion with air. This is the laboratory preparation of hydrogen. So here they are reacting with alkali, NaOH. Any metal hydroxide is an alkali, to give Na2ZnO2. What is the name of Na2ZnO2? It is sodium zincate. What is the industrial preparation of hydrogen? Which means the large scale preparation of hydrogen in the industry. So in the large scale preparation of hydrogen, what do? We actually take coke. Now you have to know the condition of the coke. The condition of the coke has to be white hot. This is very important, you have to know. It has to be white hot coke. Plus we give water. Okay, water is in the steam form. So white hot coke and water, that is in the steam. It has to be 1000 degrees centigrade, and then what it gives carbon monoxide plus hydrogen. This carbon monoxide plus hydrogen together gives water gas. This question is asked. This is water gas. So then ask you what is water gas? This is water gas. And the first step of the reaction is endothermic reaction. So this is step 1 reaction. Step 1 reaction of producing hydrogen is in the industrial process. Industrial process is known as a Bosch process, is endothermic. Number 2 is this one only. So this one will come, which is CO and H2, which is water gas. And then we give excess steam, H2O, which is excess steam. And here then we give 450 degrees centigrade and Fe2O3 as a catalyst. This is very important. These are the things that you should know. And it will give you CO2 and 2H2, CO2 and 2H2. And the second step reaction is exothermic reaction. Okay. Now our job will be to take away this guy and take away this guy so that we get hydrogen, and hydrogen in 2 steps in large quantities. How do we take out carbon dioxide? Carbon dioxide dissolves in caustic potash solution. What is caustic potash? KOH. So CO2 has been taken care of, and CO dissolves in ammoniacal cuprous chloride solution. So if we pass this in ammoniacal cuprous chloride solution, this headache is also taken care of, and we get the friend called hydrogen. So this is Bosch process, the industrial process for making hydrogen. This is step 1 and this is step 2. Pause the video and have a look and take down the notes. Now let's talk about the reducing action of hydrogen. So if you pass dihydrogen into copper oxide is black in color like this. So this is a copper oxide powder. And if you pass hydrogen through it, so copper oxide, and if you pass hydrogen through it, hydrogen is a reducing agent. Reducing agent means he's a snatcher of oxygen. He's a thief of oxygen. He will take the oxygen away from copper oxide as a family. So what will happen is once he takes this hydrogen, he will himself become water, and copper is left alone. Okay, and this is the color change that happens. This is copper, and this is how various reactions of reduction takes place, which we will see now. So for example, if we have PbO and we pass hydrogen through it, hydrogen is a thief of oxygen, so that is known as reducing agent. That means he takes the oxygen away. So he will himself take this asset called oxygen along with him, and he will leave lead alone. So this is how it is reduced. Copper we've already said. Another example is ZnO, zinc oxide, And if we pass hydrogen through it, we will get zinc and we will get water. This is the essence of reduction action of hydrogen. In case you pass hydrogen through soapy water, you'll see that the bubbles rise up. This proves that hydrogen is lighter than air. This experiment you can do it at home also. When we were kids, we used to do this simple experiment at home. Now, if you think that somebody has a business of making ghee, okay, is it possible for him to sit and make the whole day in industry? No. So cheap oil, that is cheap sunflower oil or cooking oil, can be transferred into ghee by passing hydrogen through it. So when you pass hydrogen under pressure and you add nickel as a catalyst to it, the solid of the oil becomes ghee. And this is the process of another property of hydrogen. And the property of hydrogen that we were discussing is known as hydrogenation of oil, which is just normal oil, sunflower oil. If you pass hydrogen with a nickel catalyst and a lot of pressure, you will get ghee. And this is the way industrial ghee is prepared. Taking a chance.